Hello and welcome to the episode about setting up the XGlow Pro for the anti-chicken dance feature and other connections. So first we have the XGlow, and it comes with these glow plug cables. And this cable on the top here is optional, and that's going to be required for the anti-chicken dance feature. Okay, so we're going to go to first. We're going to be using this installation. This here is going to be the first is going to be the installation of the how to do a switch driver, so that when you switch these three positions, or two depending on how you program it, you can control the XGlow to turn on the driving the plug, the glow plug. Number two is with the anti-hot start. That allows you to have the ability to know, by adding this little wire here, which is also an optional, that you plug into the glow plug cables, to add to the throttle, so that your XGlow will not start unless you have your throttle higher than idle. So if it's on the idle, the reading of the throttle will prevent the XGlow from igniting your glow plug. This Y here is connected to the XGlow Pro here, and the other side of the wire is connected to the Throttle Servo. This is the connection for the chicken dance. And the chicken dance has the same, the same throttle and all that. And the Y cable here also for the RPM sensor, so that the RPM sends signal and it goes into the flavorless unit, but it also goes into this little cable that is a third cable on this harness here, in this cable system here, where you have a remote switch to, if you want to place it in some place outside the canopy or something like that. And this other thing here, this other cable, will connect to the RPM sensor and know and tell the XGlow what the RPM is going on, but the RPM of the engine is being measured, so that their XGlow knows what to do in case of a runaway engine. So we're going to start by simulating this RPM sensor. By doing that, first we're going to show what the pulse of the helicopter, the RPM sensor of helicopter, looks like, and then we're going to do the same pulses with a signal generator that will recreate and simulate the RPM from the engine, because in order to do this video, I need to be able to show this with an engine not running. So it will simulate as if the engine is running, so you can see the XGlow trying to drive the throttle to idle, and if it doesn't work, then it burns the glow plug. So all of that is going to be shown following this. First thing we're going to do is we're going to connect the sensor, there's an XGlow sensor here, okay, to the scope, so that we can see what kind of signal we get from that. Okay, so I have it connected to the starter, and I'm going to, as you can see, there is a positive signal, and when I run the starter, it drops to 0. See that? That means all of these pulses are actually the magnet passing by the like this magnet here. See that magnet? It passes by, and as you can see here, when it passes by, it drops. So that's the way it works, you know. It drops the signal to the magnet passing in front of the sensor. Okay, so that's exactly what this will send to the XGlow. So what we're gonna do is we're gonna simulate exactly the same signals that are sent to from the helicopter, because to make this video, I need to be able to simulate what the helicopter is doing. So let's come back with the equivalent done with a signal generator. Well, we're generating a signal that is equivalent to the one that we saw on the RPM sensor in the previous view. And over here we have 30 hertz, which means that is per second, like 30 times per second. If we multiply that by 60, which is 60 seconds per minute, we have RPM. And so let's change the frequency here. Let's say we're doing, let's say 12,000, which would be 200 RPM, 200 hertz. So 200 hertz, we make it into, as you can see here, it says now 199.9, which is exactly the same as 200. So 200 times 60 will be 12,000 RPM, which would be a high-end number for the RPMs out of an engine. You know? So we're gonna use this as a running engine. So let's connect the XGlow now and see how this whole thing works. All right, so we got the signal set up to simulate the RPM sensor the signal coming from the RPM sensor. All right, so the first thing we're gonna do is I'm going to do the connections, right? If you go to the manual and look at the connection diagrams, we're gonna start with the B. Okay, the B shows how it's switched by the radio switch. So what we do, I'm going to use a Spectrum radio, okay, and I have it connected the auxiliary 1 to the switch, this top switch here. This switch here, this would be the on and off switch when I'm controlling the XGlow with that. On the throttle, I got the connection of the throttle. So we have here the switch, okay, the signal coming from the auxiliary 1 switch, and the other one is the throttle. So the first thing that you do is you connect the switch to the top portion of the top portion of the connectors, you know, the top connector here, okay? That's where the switch is. See, what happens with the switch channel is that it connects and gives power to the XGlow. Now, the second connection that we have to do is obviously the one with the glow plug, right? The glow plug connected to the bottom, all right? That goes to your motor, your engine. Okay, so let's put it underneath here. So perfect. Underneath. And let me take this buzzer off for a second. So right now we're going to concentrate only on these two, which is the positive and negative of the for the plug, for the glow plug, okay? And so this one here goes on the plug, so I'm going to connect a plug here. And because I don't have an engine here, because I need to see, I want to see the glowing of this old glow plug, I'm going to connect it directly with a little alligator clip. Okay, so now we have the signal connected from the switch connected to the top, and the glow plug connected to that. This yellow one, this yellow wire, the throttle's not connected yet. Okay, we're gonna use it plain Jane using just the switch on the radio. Okay, so what I'm going to do now is I'm going to connect a battery to the receiver so that we get the power into. Okay, so as you can see, we have now a blue signal here. You can see the blue blinking means the unit is on operation, and the yellow one, the yellow signal here, means it's receiving a signal from the switch. In other words, it is actually reading the switch. So we can turn it on by using the switch here, okay? Or we can turn it on by using the switch here. Okay? So over here we have the switch. And also because this switch has programmed the three levels, you know, the three inputs. So we have minus 100, 0, and 100. Now the middle one, as you can see here, the middle one is going to trigger the alarm that is used for locating your aircraft if it lands in like some bushes or something like that that you cannot see. This is very loud. It's very easy to see, to hear. So full means glowing, as you can see on that, you know, glowing. Okay, and that has a 10-second, which is programmable, 10-second time limit. Now the middle one is the locator alarm, and the bottom one is off. Okay, so that's the first connection. You know, the first connection then is the switch to connect that. As you can see also, like I showed before, you can turn it on using the switch, the manual switch. You can use both. If you didn't have a connection of the switch to a channel, doesn't matter, you could still use it by pressing the switch. Okay. All right, so the next thing that we want to do is, all right, go to the manual, and then you go to the connection diagram for the C, which is anti-hot start. Anti-hot start is when you connect this one here, the throttle signal, which is an optional, let me zoom out a little bit. Okay, so this optional cable here, okay, if you connect it to the throttle, okay, I'm going to bring the throttle here, and as you can see in the throttle, I have connected a Y cable. Why a Y cable? Because one of them goes into the throttle signal, and the other one goes to the servo, because we're going to read, by doing this, we're going to be reading the signal that the receiver is sending to the throttle servo. So as you can see here, now this here is reading, if you look at now it has the red LED, the bottom one. Let's show you how it disappears. See, no longer. So that means it is reading signal from the throttle. So that means this is to let you know that there's actual signal coming in. Right, when the signal is on, so let's turn it off for a second. Okay, because I want to restart from 0 again. Okay, perfect. Now, when this is connected, see, we have a behavior that is slightly different. As you can see, I can turn on, see the light here, perfect. But now let's raise the throttle. That sound, listen to it. That sound, that means the anti-hot start is active and it's protecting you from starting an engine on full open throttle. So when you plug in, okay, let me put the servo here so you can see it. Okay, see the servo's in idle and this is maximum. Okay, in idle you can turn on, press, okay, on, okay, but if I have it high in full throttle, it will not start. Okay, see that? Now another thing that is interesting is, let's say you have a bad plug, right now I'm going to turn it on. Okay, good. What if I have a bad plug? This is what happens. It's going to start to try and it's going to find out. You see that? That means it did a diagnostic on the connection, and see, this is a very different sound. Listen to it. It's all low tones. That means you have a broken plug, you know, a plug that is burned, or you have a disconnected wire. So now we connect it again, okay, and now we get back so it's going to try slowly because it is going to very slowly go up just to make sure that you're not burning something. And now after that, you know, it works normally. But when it recovers from an emergency, it will power up ramping, not fully. Okay, that's also to protect a brand new plug, because brand new plugs sometimes they like to be turned on slowly the first time. It's sort of like a break-in. Okay, so that's included. So this one can actually sense that and do it. Okay, so perfect. So now we have the anti-hot start feature going, right? The next thing that we need to do is, okay, so we already have the anti-hot start, which is C. Now you go to the D in the manual, the D diagram. The D in the manual diagram, it says, with anti-chicken dance. And the anti-chicken dance, what it does is all these other connections that you have in here. Okay, so let me go back a little bit on here. All the other connections that you have here, right? The throttle, okay, the switch are connected here. But now what we're gonna have is this port here, which is the port that allows you to have RPM sensor signal. We're gonna connect it to the simulation of the signal that we had before. So first thing we're gonna do is we have a signal here, okay? All right, and now I'm going to turn it off because we don't want to simulate that we're having a running engine, all right? Okay, so in order to get that activated, this is what we want to do. I'm going to show you two things, right? First of all, we're going to show you the protection using the servo only, and then that is option. You have red, yellow, and green. So red is no anti-chicken dance protection. Orange is only servo, and green is servo, and if it fails, then burn the plug. All right. So to do that, we need to program the unit for that. So I'm going to disconnect it, okay, and I'm going to plug it while I'm pressing this one here. And the very instant that I hear any beep, I release it. Do not stay on it, because the staying on it is for a different purpose, which is to adjust your zero on the servo. If you keep it on for 5 beeps, the servo will go to the shut off position, so you can adjust your helicopter linkages to make it match a shut off position. Okay, so like I said before, to program, you simply press this, plug it, and the first, that's it. That do was I am in programming mode. Okay, so the first one, if you go to the manual, you will see that the programming functions are 6 settings that you will find in the manual. Those 6 settings are: number 1 is throttle idle position, number 2 is glowing time from 10, 20, or full on. In other words, it will be on until you release the switch to off. This is done for the airplane guys that want to be able to have it on while landing, so they don't have a flame out on the motor, the engine. Okay, number 3 is glow driving power. This is because right now we're on driving power number 1, which is low. In some cases, some of the glow plugs, if you see, these are the let me see if I can get it to, okay. So we have throttle idle position, move stick to bottom, glow time 10, 20, 30 seconds. 30 seconds actually now full on. I need to adjust, correct the manual. Glow driving power level, low, mid, and high. That is for cases where you have glow plugs that are difficult to drive hard. So, like for instance, the Ninja 3s and some other ones. So you simply do a set, experiment and see which one is the one that you like. And this is nice because if you don't drive the other units in the market, don't really drive the glow plugs hard because they're afraid that they're going to be burning plugs. That's why we have it set up here as a default is 1, which is the lowest. But if you need more, so you can start the engine very quickly, right away after you push your button or switch, then you can set up the driving power level to mid or high, okay? Number 4 is the programming of the anti-chicken dance, 1, 2, or 3. The anti-chicken dance, if you see here, throttle idle position, glowing time, glow prior, anti-chicken dance. You have the 3 positions are red, no anti-chicken dance. Number 2 would be yellow for throttle servo only. And number 3 would be green, which would be for throttle servo and burn the plug if the throttle servo doesn't work. Okay, so we're gonna do first this one, the yellow, and then we're gonna try the green. So in order to program that, what you do is you simply go, I'm gonna go again to this here. So I'm going to go on number 1, I'm gonna be 10 seconds, so that will be 1. Glow driving power will be low, 1 again, and the chicken dance will gonna be 2, which is the servo only. Number of active magnets, it's 1 or 2. That's in case you made a mistake and you made your fan with both magnets facing the same direction. You can actually use it if you program in your radio and on the XGlow that you have 2 magnets. So number 1 is the position that I'm going to use because it's the standard one. Current for bad plug detection. That is a feature that we have, which is if glow plug is starting to fail, it starts to consume a lot of power. So this one selects how sensitive you want it. So low will be very sensitive, mid is normal, and high would be you need to be really driving a lot of current for it to trigger. If that happens, then you will have a signal, an error beep that is different. Okay, so let's put it here. So it will be throttle position, move the stick to the bottom. So this is what we do. All right, you set your position here. As you can see here, this throttle controls red, yellow, or green. That's number 1, low, mid, and high, or 1, 2, and 3. Okay, the blue keeps blinking because it's just telling you that the unit is under operation. Okay, so the first one is you put the location of your throttle where you have idle. Once you do that, you press this, it stores it, and it gives you the number of the next step. So it's going to give me 1 beep to store it and 2 beeps to tell me the next one is 2. See, the low one was to tell me is I stored number 1, and beep means number 2. Number 2 is glowing time. I'm going to leave it in 10. So now it's 3 beeps, which is glow driving power level. I'm going to leave it in low. By the way, the way I leave in low is I am keeping this here on the red, okay? Low. Okay, number 4 is anti-chicken dance. We're gonna use number 2. So it's the yellow one. See how it's yellow here? Okay, and then storage. Number 5 now is number of active magnets. I put it on 1, which is the standard. Okay, that would be now number 6. I need to current for bad block detection. I'm gonna put it in middle. That last tone means programming finished. Now we have a program for servo only anti-chicken dance. Okay, so I'm going to unplug it and plug it again. Okay, and now it's set up so that it would allow for the throttle to be driven if you lose throttle signal. So we have the unit here. So the first thing that we're going to do is now plug the sensor. Okay, but before we do that, let's make sure that we have the correct signal. Let's see. So we have here pulses, okay, going to ground, which is what the pulse is supposed to be. Perfect. Okay, and that says 200 hertz, right here, and 200 hertz means 12,000 RPM. All right, so that signal from the RPM sensor is going into this here. I just plug it in. So as you can see, let me see if you guys can see this now. Notice that the second from the top is a green light, and that green light will turn on the moment I plug this here, because the sensor is sensing the pulse from the RPM sensor. Okay, so if I turn it off here, see how it disappears. No more signal on the scope. The moment the signal on the scope goes back, we get a green light again. Okay, so that is to confirm that our RPM sensor is working. Okay, so right now I'm going to turn it off because we don't want this to start reacting to that. Okay, so I'm going to start. Okay, let me plug everything again. I didn't want to have a blown plug from the beginning. All right, so what do we have here? We have programmed the anti-chicken dance for the first, which is the servo version. Servo, as you can see here, the servo is being controlled by the throttle stick. Okay, all right, so let's say that we are running, right? This is full power, this is low. Okay, so we're full power here, we're running, and we're gonna simulate a loss of signal. Okay, so first of all, as you can see here, there is no green, so I have it already on the top of the throttle, so I'm going to run it as if it was. See, now it's in green is on because there's signal on that. Okay, so now we have that on, right? So imagine now that we have this situation where we are like that means the engine is running, is going at 12,000 RPM, the throttle is high, so the XGlow say, yeah, everything is going right. I have a high throttle and I have high RPMs. So what happens if I disconnect the throttle signal, okay, to simulate a loss of the throttle. This is what happens. Immediately notice that and see what it did. It's trying to give it 0 on the throttle, so to shut down the motor. So it does it multiple times, see? And it will not do it fully all the time because you don't want to burn the servo, okay? And so it tries to do it several times, so it keeps on doing it until it finds. But let's say that, okay, it's still trying, as you can see, right? But let's say that we have a situation where the reason why we cannot see much of the signal is because we are not receiving it's not connected because I disconnected that, right? But the moment I turn off, notice, let me raise it a little bit so you guys can see that, right? So if I move it here, you will notice that it will try to move it, see? But if I shut down the RPMs, now it's happy because it's okay, the RPMs are now 0, so I don't need to push this down anymore, okay? But if by any chance, we had again RPMs, okay, I'm gonna turn on the RPMs again, and immediately react saying, oh, something is wrong, there's high RPMs and there is no throttle signal, so I have to shut down via servo, because that's what we program, servo only, okay? So this is the anti-chicken dance servo only setup, okay? All right, so I just turn off you can actually see it here, When I turn it on, it will be green, okay? Where's that green here? Okay, green, and now, see the green there. When it's doing the error, it will not be showing. Right now it's green, is showing it. And the error is doing that. Okay, so if I turn it off, you'll see how when it comes back into display, see there's no green anymore because I just turned it off. All right, so, and that's why I stopped doing that. Now, what happens if you have a situation where you have a signal in, okay, and the servo, everything's connected, and this thing is trying, it keeps going full, but the RPMs are high, right? I'm sorry, are low, but the RPMs stay on, right? That would mean that the servo is not moving. For some reason, it's not moving, and or maybe the link between this and the engine. So the link between the carburetor and this servo maybe fell off, broke or something like that. The bolt link broke, popped off or something like that. Then what is the ultimate recourse? The ultimate recourse is to have the XGlow say, okay, let me try with the servo. If it doesn't work, then I'm going to go and do the burning of the glow plug. So to do that, let me go ahead and program that again, okay? I'm going to go with the manual. Don't forget, you need the manual to see what the actual programming steps are. Okay, so we have, again, in the manual, so you can see which ones there are. So I'm gonna program it, okay? I'm gonna do again. This time I'm gonna go fast because we already know how to do it. So I press it, push it, and I release it. Okay, perfect. Okay, so now we have number 1, throttle idle, low. So I move the throttle to low and say store that as the throttle low. Okay, blowing time 10, that's what I want. Blow driving power low, that's what I want. And the chicken dance level, now we're gonna go. Notice we're gonna go from red to green, which is number 3. That would mean servo and glow plug burning. Okay, so I store it. And the next one is number of active magnets, 1 or 2, all the way to the bottom again, 1 magnet. And then in the next one, we're gonna be current for bad plug detection. We're gonna make it middle, okay? Perfect. That last musical tone means it's programmed. Perfect, so let me unplug it, okay? Now we plug it again. And now we have it as the it's set up as the, oh, I hope I didn't burn it. Oh, I don't have any. Okay, yeah, I don't have any. Perfect. Okay, so in order to test this, instead of burning so many plugs, we're gonna only burn it once because that's what a plug will do. We're gonna put a little buzzer that will react to the burning pulse and give us a beep, saying, oh, so it's the same as if it was trying to burn the plug. Okay, so I'm using this. Let me see. Okay, yeah. All right, so that will be the same as having the plug connected. So when this one beeps, means if the glow plug was here, it would be burned. Okay, I'm gonna do it several times so we can see it. And at the last time, I'm gonna go ahead and burn the plug so you can see how it burns. Right, so we have again, I'm going to go with a high throttle right here, right? And I'm generating a RPM, as you can see that, high RPM, okay? So the XGlow is reading green, which is reading the RPMs from the RPM sensor, okay? Now what happens if I see what happened? Every time you hear that, it means, oh, hold on for a second, I disconnected it got disconnected, so let's connect it again. There you go, connected again. Okay, so every time you hear that big beep, that is trying to, and that happened because I went to idle, but the sensor still sensing all these RPMs, right? And it's saying, whoa, I need to, so it tries first to kill the servo, but because it's fully connected, and and the link is what broke, let's say the link came off or something like that. The only recourse that it has is to burn. Okay, so now I have it full on, so that stops. So same what happens is that if we had it off, okay, so if we have this situation here, okay, it will do this, send it to minimum. And if it cannot find that the RPMs went low, it will then try to burn it. So again, if I lower the servo and it's still fully connected, it will do it by killing the glow plug. But if I do it by, let's say, have it up, if the servo signal fails, it will try to do that and then try to kill it if it doesn't see that this one stopped. Okay, so now I'm gonna just show how it's burned, so let's do that. You simply replace this one with the, okay, so we're gonna have this one and facing us. Okay, so where's here it is. Okay, so we're gonna use this alligator clip, okay, to have the connection of that. All right. Yeah, right now it's not going to allow me because it's on high. Okay. All right, so we have it running right now, okay? All right, so what happens if I have it up here? I have RPMs, as you can see here, okay? And so what happens is that it's going to try to move that, but it won't be able to, okay? Because it's connected. And because I'm going to lower the RPM, the throttle to 0, and it's continuing to read that there's RPMs, high RPMs. The moment I drop the throttle to 0, this, pay attention to this, okay? Notice how this is going to burn. So let's waste another glow plug for this. So I'm about to come down right now. I came down. That's it. See? It killed it. So now there is no plug. So if we try to start this one, we're gonna have okay. So if we try to start this, it's going to sense that there is a problem with it, and it's going to start giving us this, which is a burnt glow plug, which is what happened because it is a broken element, as you can see in there. So that's how it does it. So this is the way you burn the signal, and it's also done in a very high-tech manner. The way that happens is done by sending pulses and sensing stuff. It's just pretty cool, right? So that's how you make an XGlow do everything but bringing you a cup of coffee. So hope you guys enjoy this, and I hope you guys don't have any chicken dances if you set it up like this. All right, thank you. Bye bye.